Okay, guys, let's begin. I know we're gonna start configuring Arduino today. Let me apologize for my voice, and I'll try to keep the coughing to a minimum. But I actually have a cold, so. But anyways, before we get into the Arduino, there's just a couple of concepts I want you to understand in their simplest forms. That is the difference between digital and analog communications, because that's actually what we're going to deal with today. In our nightlight, we're actually going to be able to see portions of an analog signal, because we're going to build our own little analog light sensor. Anyways, so what this is you can think of this, and actually I probably should have done a better job at it, but this column here, think of as voltage. Think of this right here as 0 volts. This line going across here is 0 volts. And let's think about this top line as 5 volts. And so this is 0 volts, this is 5 volts. So that's the scale in this direction. In this direction, it's time. It doesn't matter whether it's seconds, milliseconds, nanoseconds. Just think of it as time. So what happens is we slowly see a voltage increase until, of course, it peaks at 5 volts, and then it slowly decreases over time. So at this point here, we're actually seeing 2.5 volts, and down here it's in half again, of course, and here is 0. So our analog signal is basically consists of the ability to move between many voltages. And this is going to be true for our Arduino sensors. And like I said, we're going to go over this in more detail. We're actually going to do analog to digital converters and digital to analog converters on our Arduino. But the digital signal is basically either on or off. Once again, think of this as voltage. This is our voltage scale. The bottom here is 0 volts. The top is 5 volts. And this is time as we move across. So you see, as we move across time, we're at 5 volts, and then boom, we jump down to 0 volts. And then, we hit a time period and we jump up to 5 volts. This is digital. Digital is on and off. Ones and zeros. We're going to get into that when we do binary, hexadecimal, and dotted decimal conversions, which we will do. I know I keep mentioning it, but we will be doing it. And the only reason I'm putting it off is because I want to get a couple of these Arduino example programs, example tutorials out of the way so that you guys can get started on that as well. Okay, we're not going to deal with these waves. These are waveforms. So the only thing we're dealing with right now is we have what looks like an analog signal and a digital signal here. So basically, when we read, we're going to have analog pins and digital pins on our Arduino. And when we read an analog pin, it could be anywhere from 0 to 5 volts, anywhere in between there. When we read a digital pin, it is either 0 or 5 volts. There is no in between. Okay, so anyways, we have our analog signal and we have our digital signal. And when we read these digital pins on our Arduino, analog can read anywhere from 0 to 5, which means it can be, 0.47 volts. It can be 4.93 volts. Our Arduino converts it into numbers from 0 to 1024. So we have 0 to 5 volts. When we take a reading, it'll read 0 to 1024. And once again, on the digital pins, it's either 0 or it's 5 volts. Nothing in between. Okay, now that we've got our Arduino installed, I'm very glad that we did get it installed. On this particular laptop, it took a little while. Here's our Arduino interface. Now, I have my Arduino plugged in, and I've got a separate video camera running, so I actually have to start editing my videos to cut in the portions that I have on the external video camera. So this is our IDE. This is our interface. And I guess I should talk about this a little bit first. Okay, we have a series of icons here, and we have a series of menu options here. Under File, we have New. It's new. It's create a new sketch, actually, and it will open a new window. We have Open an existing sketch. Sketchbook. When you save your sketches, they will be in here. A lot of my sketches are in here. Like I have my GPS logger and all kinds of other things in here. So you don't necessarily have to go open. It'll actually be populated in your sketchbook, depending on what subfolder you save them in, and we'll get into that later. Examples. There are many example sketches in here. And as a matter of fact, we will use the first example, Blink. I'm going to put that aside. We're actually going to run through that before we build our nightlight with our sensor. We got to learn a little bit of the language first anyway. There's close, there's save as, upload to I/O board. That's uploaded to your. Actually, once you, let me just mention that. That's one thing I forgot to mention. Once you upload your program to this microcontroller, you can then unplug it from your computer, and you can power it here. I heard you can use up to 12 volts. I actually put in 12 volts in here. I actually fried one of my Arduino trips once, so it was through a car battery, so I think it was actually more than 12 volts, so it wasn't a regulated 12 volts. You generally take a 9-volt power supply, and you can run this perfectly fine off of this without being plugged into the computer. We'll just keep that open in case we need to reference that. Okay. I'm not going to get into page setup, print, preferences, edit. These menus, anybody familiar with Windows should be fairly familiar with most of these things. Find, copy. Sketches. Verify and compile. Very rarely do I use these menu options up here. I usually use the buttons, and I'll show you what those are in a minute. So verify and compile your sketch. Show sketch folder. Input library. There's one you'll use. Let's say you want to do liquid crystal displays or software serial. We're actually going to use serial today to monitor our analog, our light sensor, and we actually have a sound sensor too that we're going to use today. And we're going to use the serial to monitor those. But let's say if you wanted more serial connections to more devices, you could use software serial and create any of your pins as RX and TX TTL serials. So there's a whole bunch of stuff here. These are all libraries, and there's many more libraries out there. Adafruit has a whole ton of libraries that she has new color displays, color touchscreen displays, where she has a library that you input so that you can manage that color display using the Arduino. Okay, tools. Okay, tools are important. There's two places in tools that are very important. One is the type of board. And like I mentioned when I was installing it, I'm actually using one of my older ones, which is Demulov, and I apologize to any Italians out there if I'm not pronouncing it correctly, AT Mega 168. It's just an older one. It doesn't have as much memory as the 328. And these guys are basically identical. As far as what the chips can do, the chips are identical. It's just the boards themselves. There are some differences, not enough that I'm going to get into. If that's something, Adafruit actually on her site gets into the differences a little more. I'd rather focus my time on other things. So if you go to her site and she can describe the differences to these, has nothing to do with the programming of it or what it can do or anything else. It's just the board itself. And so you may want to make sure you have the right board selected, and you want to make sure you have the right serial ports selected. And of course I only have one. And if initially when you first come into this, it doesn't automatically pick up whatever COM port you're using for your Arduino. If I showed you my old laptop, you'd see like 14 COM ports here, because every time you plug in a new Arduino, it gives you a new COM port. So you got to make sure that you actually select that. If there's no checkbox there, it's not selected. So this is our Arduino. This is our interface. Now we have help. There's a lot of stuff here. Visit the Arduino site. I spend most of my time selecting the reference. Now what happens when you download the Arduino software, you'll notice that it took me to local on my hard drive for this reference material. So what happens is, if you look on the site, you may have newer reference material than the version of your Arduino. So it's always good to use the references from the Arduino interface itself to make sure you're referencing for your version of code, or just download the latest and greatest version of code and then go to the site and you can do it there. So this gives us a lot of information. We're going to deal with data types today. These are called variables. We create variables using data types to store information. We have digital pins, and so if you're ever wondering, and you can jump ahead, go in here and say, well, what is this analog write pulse width modulation? We may not get to this today, where we actually use pulse width modulation to write to... Sorry about that. That was the phone in the background. So you may want to jump ahead and start playing with this stuff. Okay, so let's go back to our interface. We'll keep this open because we're going to use the reference. Or actually, you know what? We can close the reference. We can get it easily enough right from the help menu. So there's a lot of stuff in here. Most of it takes you back to the website. Some of it takes you to your local hard drive where you install the software. Some of the earlier versions didn't have it locally. It only had it on the web, and it used to drive me crazy if I didn't have web access and I was trying to look something up. You're not going to memorize everything in programming. You're always going to refer to reference materials. Okay, so let's take a look at our first sketch. This is our Blinky sketch. Okay. So basically what you're seeing here is there's two ways to display comments. Comments are ignored when you upload it to the chip. It doesn't actually get sent there. Comments are for you so that you can understand what it is you wrote. And believe me when I say you need to comment your code, especially when it starts to get larger. As an example of that, let me open processing here. Now, you can use any software language you want to interface with your controller. When you build your controller, let's say you want to show graphs from sensors or something, you can use Python, you could use C, you could use C++, you could use Visual C++. I use processing. You may notice that the interface is very similar to the Arduino. It was developed at MIT, and it's more than just a Java library. It's its own development environment, but it does run on Java. But let me get to why I brought this open. Example, sketchbook, games. I'm actually going to start a... Sorry about that. I'm actually going to start a second set of tutorials on programming with processing. Normally, you notice the color scheme is different. I did that. When you first load processing, if you go to processing.org, you'll get the same thing you see on the Arduino. I actually changed this. Now, you're going to notice here, in this program, there's a lot of code here, and you notice I have a lot of comments. And that's just the main program. I haven't even gotten, this is just creating lightning in the game. And, and this is the class, the managers. This is the things I'm shooting at. Timer, and so you need to comment because, if I don't touch this for a little while and then I go back to it, I'm like, where was I? How did I do this? And at the end of this video, I'll actually show you that game I'm developing if you're interested. So you definitely want to comment all your code, because you will forget it later. Even in the microcontroller world. Well, that was just a simple GPS logger. Here is, well, I'm not going to find my GPS stuff right now. Anyways, okay, so now we have, these are comments. There's two ways to do comments. So if you do a /, see if now if I delete this, it all becomes comments. If you do a / asterisk, you could type anything you want, and then you do an asterisk / to end the comments. So if you're going to do like a whole paragraph, you could do it that way. But if you just want to add something to the end of a line, or if you have a single line, all you have to do is do the double / and then type away, and then your next line you're back to not being commented. And like it shows here, this is actually code and this is comment here. Okay, now there's two functions in almost any program you're going to do. You're going to have two functions with Arduino. You're going to have void setup and void loop. The void, I really don't want to get into right now. It's a return value. We're not returning anything. That's why this is a void. And I'll explain that later when we go over to functions. But basically you have setup. And it's things that you want to do once. You know, pin mode 13 is going to be output. Well, pin 13 is always going to be an output. We put it here. It's done. Looped actions are what go in here. The things that get repeated over and over again, or where you make control decisions, stuff like that goes into the loop. This is the main body of your program. This is where you set it up. If we were using processing, or and these are also called methods. Some people know them as functions. Some people know them as methods. If we were using processing, sorry, I lost my train of thought for a second there. So you have these, they're called methods or they're called functions. And, I remember what I was going to say. If we were using processing, let's say we were going to add sound and graphics and all these things to our program, we wouldn't want it to load every time the program ran through the loop. It starts up here, it comes down, it comes back. What we do is we'd load all our sound and our graphics up here in setup, and we'd load them once into memory, and then we'd use them down here. That's the most practical example I can think of. But for right now, for the microcontroller, anything that we're not manipulating can go up here. You know, when we're setting up all our pins to what they're going to be, they can go here. Anything outside of these two functions, like if we put some variables up here, which we will do, we're actually going to change this a little bit. We're going to change this code a little bit. And then we're going to change it and turn it into a light sensor. So we're going to go from a blink sketch to a light sensor. So the first thing I'm going to do is I'm going to say Arduino code for nightlight. Okay, so any variables we put outside these two here are considered global variables and can be used anywhere within your program. What is a variable? Well, a variable is a name for something else. You can think of it as an identifier. Let's actually go into the help, the reference, and you can see an example of it. Now, the first thing you do when you create a variable is you're going to determine what type of variable you need. And if you notice, there's void here, but there's boolean, which is true, false. There's character, which is A, B, C, D. Unsigned character, byte, init. Init is what we're going to be using now. And I find that most of the time I use init, I use long, I use float. Well, actually, I use init, float, and strings a lot. But we're going to be using inits today, so let's look at init. So INT stands for integer. And what you're doing is it's basically a data type, and it's for number storage. So we could take a number like that LED pin, that pin 13, and instead of using the number 13, we could say init. We're going to use an integer. We're creating a variable of an integer. We're going to call it LED pin, and it equals 13. So now in our program, anytime, instead of using the number 13 everywhere, well, let's go back to our program. See this program here? Now, if I wanted my LED pin now to be pin 5 in my program, I would have to change this to a 5. I would have to change this to a 5. I would have to change this to a 5. So, I mean, that doesn't seem like a big deal right now, but this is one of the smallest programs that you are going to work with. So when you get larger and larger code, like I was showing you earlier with processing, that I have variables that span all those classes, you don't want to see everywhere where you use that number and then have to go to change it everywhere. So basically, you want to use variables any way you can, and that's exactly what we're going to do here. We're going to create a variable, init, and we're going to call it, let's call it, nightlight equals 13 semicolon. You need a semicolon after every one of these. After all your command references. If you notice, each function, it has these parentheses, and then it has the curly braces. And so we begin the setup here. Basically, these functions, sometimes you can send data to a function to have something done and then have it return a value. Of course, if it's not returning a value, it's void. But you would have the data that you were sending to the function in here. We're not sending any data to either of these functions. So that's what these parentheses are for. And then the curly braces encapsulate the code for this function. So we've got the void setup, and this curly brace starts the void setup, and this curly brace ends the void setup. So what we're going to do is we have init nightlight equals 13. So now what we can do is we could say, now it seems like more work initially, now that we're changing all these to nightlight. But now in the future, let's say we had a lot of code here. We had pages of code. We wouldn't have to go look for it. If we wanted to change this to pin 5, if we wanted pin 5 to be our nightlight, then boom, 5, and that would be it. It would change. So what gets uploaded is not nightlight. Nightlight doesn't get uploaded to your sketch. What gets uploaded is the number 5. So this compiles this all for you. You're doing this to make this code more readable for you. Okay, so this is a variable. We created our first variable. Well, we're going to need a couple of more variables for our nightlight, but let's not create them yet. Let's figure out what code we do have here before we start creating more code. Okay, so we have pin mode. What is pin mode? Well, pin mode 13 output, that tells me basically that we want pin 13 to be an output. But if you're ever confused about any of this, you just come back to the reference material. Configures the specified pin to behave either as an input or an output. See the description of digital pins. So this is a digital pin command, and because when we do our analog read, we don't have to do pin mode for our analog pin and call it, say it's an input. These are for our digital pins right here, this pin mode. So basically what that's telling me is, okay, so now it's pin 5. Let's make it pin 13. Pin 13 actually has a resistor in it. You can use an LED in there without having to put your own resistor. Remember, all these digital pins are 5 volts. It's too much for an LED. So you'd probably need anywhere between a 220 and a 470 ohms resistor. But pin 13 already has a resistor, so we're going to stick with pin 13. So basically, we're telling the Arduino microcontroller that pin 13 is going to be an output. Okay, now we come down to our void loop. So we have digital write, nightlight, comma, high. Set the LED on. Well, once again, let's go to our reference material. Digital write. And like I said, it gives you examples of these as well. So it describes it in full for you. 5 volt or 3.3 volt for if you buy a 3.3 volt Arduino. They do have them. But most of the Arduinos we're going to be dealing with, all the Arduinos that I'm going to be doing my tutorials on are 5 volt. So, there's tutorials on here. This site, there's so much on this site. Like I said before, I may not even have to do tutorials, but I'm going to do them anyways. People seem to like the video tutorials. Okay, so back to our sketch. That's what these are called. They're called sketches. Programs, sketches, whatever you want to call them. So digital write, I'm basically turning on that pin. I'm saying turn that pin on. Delay, 1,000. Wow, that seems like a lot. It's actually not. It's 1,000 milliseconds or 1 second. Once again, the reference. I'm telling you, this reference is invaluable. So we have delay. We have delay in microseconds if you want to create even a smaller delay. And once again, it gives you the examples, and it tells you it's in milliseconds. So it's for 1,000 seconds. Oh, let me get rid of that processing. And digital write again. Nightlight, which is pin 13. Low. Set the LED off. And, of course, if we went back in there, you would see that. And then we have delay a second again. So, and this will loop over and over and over again. So what does this say that this program will do? Well, this is going to take the LED pin and light it up for a second, shut it off for a second, light it up for a second. So it's going to be, the original sketch was blink, and that's what it's going to do. Okay, let's get to these icons here. This is verify. Now that I've built my code, I select that button, and it's compiling my code. And this is a stop button, of course. We have new, we have open, we have save, if you want to save your sketch quickly. And, oh, I have to save as because this is an example program. So we'll call it my nightlight, one word. My nightlight. It's going to put an underscore in there. Oh, by the way, if you, under your documents, if you have documents Arduino, that's the default for all these sketches. So when you do that, the sketch will then appear, my nightlight. The sketch will then appear under your sketchbook. So instead of going File, Open, and finding it in some other directory, it'll appear right in the sketchbook. Okay, let me start the video camera before we do the upload. Okay, so the next button is upload. And of course there's serial monitor, which we'll get to shortly. But, so we had save. Now I can select the save button and it just saves it. Now we have upload. What we're doing is we're uploading to the microcontroller. So I'm going to hit this button, and you're going to see it uploading to I/O board. Let's go. Back here. See this right here? You just saw the transmit and receive LEDs. There's actually, pin 13 has a built-in LED, which I assume is why it has the built-in resistor. So that is what you're seeing flashing when I showed you that little sketch. But what I'm going to do right now is I'm going to put a regular LED in there. Okay. So what you saw there with the flashing, see, this is pin 13 and this is ground. So the long end, the positive end, goes into this side, and then the short end goes into ground. And so now we have our little flashing, blinking light. Also, I'll go over this a little bit with you while I have this open. 0 to 13, these are digital pins right here. The ones with the little tildes next to them, those are capable of pulse width modulation. We're not going to be doing this on this lesson. Probably our next lesson we'll use pulse width modulation. This is RX and TBEX. This is the same thing as you saw with these lights over here. This is receive and transmit. So not only are they digital pins, but you can plug into another device, like a GPS or any other device, actually, and have it communicate to from the Arduino using those. Or you could use a soft serial library and make any of these pins transmit and receive to talk to other devices. When we get into the code for the university, we built a GPS for the bus system that I'm going to review with you and publish all that as well. But anyways, back onto it. Okay, so down here we have our analog pins. See with the A's? We have A5, so 0 through 5. So we actually have 6 analog pins that we can use for sensors here. We also have VIN, which is volt in. We're not going to be dealing with that right now. We have 2 grounds. Then we have 5 volts, we have 3.3 volts, and we have a reset. So what we're going to be dealing with today is this 5 volts and a ground. So we're going to be using a 5 volt and then one of these grounds. It doesn't matter which ground you use. Either one of these grounds will work. And we're going to, when I say pin 5 for analog, this is the pin we're going to use. And we're still going to use pin 13 as our nightlight just for now. Okay, so let's go back to programming the nightlight. Okay, so right now we don't have a very good nightlight. Right now we have a light that comes on and shuts off. It comes on and shuts off. Well, we're going to need a light sensor, right? So one of our pins is going to have to be a light sensor. So let's create another variable. It's going to be an init, an integer, and we'll call it light sensor. And I think I already gave away the farm when I said it was analog pin 5 we're going to use. So that's going to be our light sensor. Well, not only we're going to read that information from the light sensor, but we need another variable to store that information once we read it. So we're going to create another variable called init sensor value. And initially, that's going to equal nothing. We don't want that to, that's going to equal 0 for now. But let's go back into our reference material, and let's look at it in it one more time. Because our sensor is going to read from 0 to 1024. Well, according to this, we can do a 2-byte variable that goes from negative 32,000 to positive 32,000. So we don't need to go to another variable that can store information like a long. A long uses more memory, but a long is, you can see you can store much higher numbers in a long. But it takes up more memory, so we don't need to do that, so we're not going to do that. Okay, so that we see our sensor, we have our sensor value. Okay, so how do we configure a sensor? Do we have to do a pin mode on it? Okay, I'm being facetious. I should stop that. Okay, basically what we're going to do is we're going to do an analog read. So let's go back to our reference. So we have our analog functions here, and we have analog read, analog write, which is pulse width modulation. And the pin number, you notice there's a digital pin 5 and there's an analog pin 5. The code knows which pin you're referring to based on the commands you're using, so you don't have to worry about that. Okay, let's just do this. Okay, so we're going to do an analog read. And we're going to do pin 5. I could type in 5 here, but I did a variable called light sensor. So it's going to read that pin for me. Okay, now what? Well, we read the pin, but how do we get the information? Well, here's what we needed that second variable for. So one of the things I could do is very easily just say sensor value equals analog read light sensor. So now whatever it reads will now go what is this? Sensor value. So now whatever is read from that pin will be stored in this variable. So the first variable, we're telling it what pin to read, and then we're taking the results of reading that pin and storing it in this variable. Okay, so we're getting a little closer to our nightlight here. So now we can read our light sensor. We haven't built our light sensor yet. We're just writing the programming for it now. We'll build it in a minute. I want to get the programming done before we do any of this. So now we need to make a decision based on this sensor value. And we can do that, and I call them conditionals in programming. And Arduino, they're called control structures. So what you do is you have control structures. You have if, and most of these are what they sound like. You know, if this equals this, do this. If this equals this, do this, else do this. That's the one we're going to use. There's for, there's while, there's do while. While this sensor is at this reading, keep the light on. So there's many ways you could actually do this. But, okay, so we have our conditional. And here is our if conditional. And we need to use comparison operators with them. If it is equal to, if it is not equal to, if it is less than, if it is greater than. We're actually going to use, I think we'll use greater than. So remember, it's not 1 equals. In a comparison operator, it's 2. Equals equals. So if some variable is greater than 50, then do this code. So let's start there. If sensor value is greater than, and this is supposed to go up to 1024. We have no idea what our sensors are going to read right now, so let's just say, let's split the difference and say if it's over, we'll call it 500. Now, I'm used to doing my code another way. I don't like the way they have the brackets here. I usually do it another way, but you need the curly braces. So the curly braces will determine the functional code within our if statement. So we start the curly brace. Now, if you want to do it their way, you can start the curly brace here, put in all your code. You know, however many lines of code you want, and then put in your other curly brace. As a matter of fact, let's stick with that. I don't know if the way I do it would be considered a bad habit, but the way I do it in processing is I keep it right off of this here. So basically, what about our code? What are we doing for our code? Well, our code is actually right here. If it is greater than 50, let's see. Now, let's think about this. Our light-dependent resistor, the darker it is, the less electricity that passes through. So the lower this number will be. So let's actually use a less than. So if it's less than 500, we want our light to light up. Now you can just copy paste the code. I find it's actually better to type in your code. You actually learn it more, learn it better, learn it quicker. Okay, so if sensor value is greater than 500, turn on the light. But what if it's not greater than 500? Once the light comes on, it's going to stay on forever. So let's actually get rid of this code here. So now we want to do an else. Else, then we would do digital write and this is case sensitive, guys, and then another curly brace. Notice how our curly braces, actually, let me get rid of that curly brace and see what happens when I verify. Boom, it tells me it expected another curly brace there, and it didn't see it. So we have a curly brace at the beginning, and I'm sorry, I just can't deal with that. I got to put this here. This is how I'm used to doing this. Curly brace here, and then more code. I could have another. I could put a delay in here if I wanted to, or have it do all kinds of things. It's not just one line of code. That's just what we're using for now. We're keeping our first program simple. But we can have many, many lines of code. If the sensor value is less than this, we can have it do 7 different things. Okay, just to make it a little more readable. And then we have our next line of code, which is our else, and then else do everything between this set of curly braces. So if it's less than 500 with electricity coming through, then turn it on. Otherwise, turn it off. Okay, so that code should work. And we compile it, and it's compiling fine. But we don't have our light sensors hooked up. So now we need to discuss the sensors. And I think we're going to go over to the video camera for that. So let me pause this. Okay, guys, there's one more piece of code before we should go to our breadboard. And what happens is we need to see what this value is to make adjustments to our code, to know when we want the light on and when we want the light off. We need to be able to see that. Well, there's an easy way to do that in Arduino, and it's through the serial monitor. Okay, and we do it, we open up the serial port with and then we put in the speed of our, by default, your serial monitor should be configured to 9600. You'll see different speeds for different devices. I think I had to kick it down to 4800 for the GPS. There's 2400, you'll see 115,200. So it can get a lot faster, but for our needs, 9600 is perfectly fine. So we've got serial begin, and we can go to our forums, not our forums, but to our reference. I don't think that command, oh, right here, serial communications. And see serial begin, serial end, available, peak, print. We're going to use print line. So we've got serial begin, and it just tells us use the speed, what speed it is, and it gives us an example. And we do that in void setup. And then once it's open, we can do a serial print. And we can do, put in any value we want in there. So let's go back to here. So down here we want serial.println Sensor value. So now what we're doing is we're sending whatever this value is to our, make sure that's off. Whatever that value it is, we're sending it to our serial monitor. Okay guys, sorry about that. For some reason I had to change COM ports. Let's go get our nightlight sketch. Serial port COM4. And we switched over to a 328. And we verify our code. And then upload it. Okay, it's been uploaded, and just for your reference, the LED light is on, which means whatever the value is, it's less than 500. But to see that value, we just select the serial monitor, and see, even though we have nothing connected to it, it's still got a reading here. And this is just what it's picking up just from the air. So, but we needed to do this before we start going over to the board and start putting it together. So let me stop this for now. I'm going to pause this video and we're going to go over and we're going to build our light sensor on the Arduino. A little bit here. We upgraded to a 328 chip. I don't know what happened to this guy, but he wasn't communicating on COM3, and if I didn't want to, get behind days on producing this video, I needed to do something quickly. Okay, so one of the things we need to do is we need to get our 5-volt power. So I'm going to go, like I showed you in the video, it's the third over from the left, so we go reset 3.3 5-volt. So I plug 5-volt into the 5-volt power rail, and then ground into one of those ground ports. Right next to the 5-volt is another ground port, so I could plug it in right to there. So that's plugged in. So now we have power for this. The next thing we want to do is we want to take our light sensor, which is our LDR. Now a sensor can be anything. As a water sensor in my plant at work that I have automatically water itself, it's just 2 stainless steel screws. I have 5 volts going to one screw, and the screws aren't touching, they're just planted in the dirt, and then I have the other screw going to ground, and I have a sensor reading off of that to tell me what the moisture is, and the more moist the soil is, the more current that gets through, the more electricity that gets through. Voltage is what we're actually measuring. So the thing is now I could just take this if I wanted to, and we'll just take 2 orange, and I could say, okay, we're going to go power over to our LDR, and then we have nothing, and we're going to analog 5. So then we could go, and actually I'll tell you, I'm putting this in the power rail, and then I'm putting it in J10. Power rail and then J10. And this one, if I put it to ground, it does us no good. It just creates there's nothing getting measured. We actually need this to go to analog sensor 5. So when I plug that in there, just like this, the readings we're going to get are they're going to stay high. They're never going to go down. Let me start the video over here and show you. So now, if I open the serial monitor, look at this, 1023. It just stays as high as possible. And that's because there is nothing, and whether we block the light or not, it just stays at that rate. The reason for that is because there's nowhere for that current to flow. There's nowhere for that electricity to flow. So we need to supply it with a path. Now what I could do is just take another connector and then put it to ground, but that would do no good either. If I did that, that would just have the opposite effect. And it did. I just did it. It had the opposite effect. It brought it down to zero. Because all the current's flowing to ground instead of flowing to that sensor. So what we need is we need a pull-down resistor. So we need something that prevents all the current from going to ground and leaves enough that it can adjust to the analog sensor. So I'm putting this resistor in A10 and then into the ground. And hopefully you can see what we have here. A10, and notice our light sensor went off. And when I cover this, see that LED comes on? Now I just guessed at that number. We're actually going to go look on the screen while I put my finger over these and see what happens. But this is a pull-down resistor configuration for a sensor. And it's not very difficult. We go from positive power over to the LDR. On the other side of the LDR, we go into the analog sensor pin, into the analog sensor pin 5, and on that same segment we take a 10K resistor and we go to ground. And even on my water sensor I had to do the same thing. 10K is usually a pretty good value resistor for a pull-down resistor. There's pull-up resistors too, and we'll get into that with our first motion detector. Okay, I'll leave that running. And is this still running? Yeah, we're still running here. Okay, so now let's look at, now that we have the pull-down resistor, we can see that there's the value. Now watch what happens. When I cover it up with my finger, the value goes down. So I barely picked a good number because it's barely getting below 500. So we could adjust that value if we wanted to. And since I've got that running, let me put this pin back in. Okay. So here's our first microcontroller program. So basically, if it is 500, we need to change this. Now, we could actually make it so it has to be a lot darker. I can't bring this into a darker room and show you guys. 500 for the LDR you're using may work fine. If I actually turn off the light in here, it actually comes on. So it's 500 is actually, let me see if I turn off the light in here, it comes down to, yeah, 459. So 500 is actually too high a number. So I would bring it into a room or bring it into a light, into a room that had the amount of light that I wanted it to come on, and I would put it in, you know, whether it was 300, if we did 300 now. So by changing this one, now I could put a variable here as well. I could say init. If I wanted to, I could put another integer in here, and of course some of these variable names are a little long. You can make them shorter if you want. And call that 500, and then down here light strength, or you know, LDR, whatever I wanted to call it. I compile it, make sure. Unexpected, unqualified ID before numeric constant. Oh, I forgot my Okay, now we verify it again. Light strength. And again. And done compiling, and then I upload again. And done compiling, and then I upload again. And it's basically the same thing. Light off, light comes on. Light on. Now you may think, well, that's an expensive nightlight. Do you really want to... Or actually, I had a student say that to me. That, why would I spend all that money to make a nightlight? And you wouldn't. But it's a lesson in sensors, and it's a sensor you may have on a robot. Maybe your robot has headlights that automatically come on when it gets dark enough. And so if we were using, and by headlights, I mean headlights, not little LEDs, but some bright lights. Because as we go on with our microcontroller stuff, we're going to learn to control very powerful things with very little power from the microcontroller using relays. As a matter of fact, the self-watering water from the internet plant that I have, Bob, he is actually it's an AC water pump that I have connected to him. And that AC water pump is controlled by the Arduino through a microcontroller, through a relay. Okay, I think that's enough for one lesson. Let me save this now that I can save it this way. Let me just run over it quickly. We have 4 variables. We have nightlight, light sensor, sensor value, and light strength. I don't know if I named that. That should actually be named light strength. But we have a pin mode for our digital pin. It's an output. We have our serial.begin for our serial communications to monitor the value of our sensor. And I don't know if I can do a split screen on it, but okay, so then we have our loop down here where we have our sensor value. So it's constantly, at the beginning of every loop, it's reading the light sensor. So it's reading pin 5, analog read pin 5, and it's storing whatever that is in this variable called sensor value. Then serial.println, it's printing whatever that value is, and the ln stands for a new line. If we use the serial.print, it would just go scroll across forever. It would never, there would never be a carriage return. So this actually gives you a carriage return at the end of this. If sensor value is greater than light strength. So if the sensor value is greater than 500, did turn the night light on. Digital bright, pin 13, turn to high. Else, turn it off. And that's it. And of course, if I select here, you can see that this curly brace encloses all this code here. If I go here, I see this curly brace relates to that curly brace. This one relates to that one. That should be about it. I think I'm going to just use the other camera so you could see what I was doing. I don't know if I could have both of these play at the same time. But when I was putting my finger over the sensor, you were seeing the value go down. Now you see how fast this 9600 baud is. I mean, we could go up to 115 too if we want to. There's really no need for it. I think that's enough for this first lesson. Hopefully I get everything. Like I said, I'm suffering from a cold right now, so if I missed anything, I apologize. Just let me know, and I'll make sure I get it in the next video. Once again, let me just do a close-up of this and see if I can explain this a little better. I'm actually going to unplug it and bring it up here for you guys. Now what we have is we have this red wire running from the 5-volt positive, because this board supplies us, this board is giving us, it's got a regulator on there, and if we had a 9-volt plugged in here, we'd still be getting 5 volts out of this. So these boards are handy for developing, which is another reason I recommend you start with these. So basically we took 5 volts here and brought it over to our board, brought it over to our proto board. Then we took, we also brought ground over to the Arduino, is our ground. And then we brought the 5-volt positive over to one side of the LDR. It doesn't make a difference which side because there's no polarity. And then on the other side of the LDR, we go from the other side of the LDR into the analog pin, into our analog sensor pin right there. But when we did that, it stayed at 1023 at the highest voltage, because there was nowhere for it to go. It doesn't drain through that pin, so we've got to give it a place to drain through. So what we did was the same connector on that side where we have the actually I could even have put it in here. I think I did that for the plant, was I put it in the pinhole itself and then right over to ground. But what we did was we put it on the same side over here as the analog interface, and then into ground, and then ground runs into here. I didn't have my computer pen with me, so I didn't draw this out at the first. But if anybody finds it confusing, let me know and I'll review it the best I can. But it's a pull down resistor, and maybe at the beginning of my next video I can explain a little how the pull down resistor works.